Welcome back to the deep dive. Our goal here is always pretty simple. We take these dense, sometimes really formal specifications and documents, and we try to distill them into knowledge that's, understandable and actionable.
And today, we're really focusing on this idea of specialization, but specialization at scale. I mean, for the last few years, we've all been blown away by the general power of these big models.
Oh, absolutely.
The agents that can write an email, summarize a report, even spit out some decent code, but there's a but. When the rubber really meets the road, when you ask them to do reliable, repeatable, actual work, they tend to hit a wall.
Yeah, and that wall is always context, isn't it? They're incredible generalists, but they just don't have the playbook for your specific company with your specific rules and your specific legal processes.
Exactly.
You can't just ask a general AI to handle, I don't know, a multinational's legal review for entering the German market. It has no idea what your specific internal 50-step process is, and you can't afford to teach it.
And that gap, that space between general smarts and reliable execution, that's exactly why agent skills exist. It's what we're diving into today.
So what are they fundamentally?
They are a simple but really powerful open format. The whole idea is to package up that domain expertise, that procedural knowledge, into a standard portable little container. It's how you give a generalist AI a custom on-demand library of expertise.
And for our source material on this, we're going right to the source. We are digging into the formal documentation, the actual specification for the agent skills format.
Right. This was originally developed by Anthropic, but the key is that they released it as an open standard, which is why we're even talking about it. It's becoming foundational to how enterprise AI is being built.
So the mission for you, listening to this, is to get beyond just knowing what skills are. We want you to really understand the mechanisms under the hood, the architecture that lets these agents scale up their abilities without, just collapsing under the weight of information overload.
Yeah, that's the engineering magic right there, how they manage the context.
Okay, so let's start at the 10,000-foot view. If we strip away all the technical jargon, what is an agent skill?
At its very heart, an agent skill is just a folder, a structured, self-contained folder that acts as a little knowledge package.
That's simple.
That's simple. And inside that folder, you've got instructions, you might have some scripts, some other resources, all laid out in a way that, crucially, both a person and a machine can easily read and understand.
I really like that framing. It's a mechanism for on-demand context. That's the key. Instead of trying to stuff every single company procedure into one giant, expensive prompt.
Which would never work.
Right. It would be a disaster. Instead, you're just giving the agent the specific manual and the specific tools it needs for the job at hand right when it needs them. It's just a really elegant solution to a massive problem.
It really is.
So let's dig into the why. Why did this standard even need to exist? We've sort of touched on the problem agents fail at real-world tasks. But let's get deeper into what that how-to guide, that procedural knowledge, actually is.
It's a huge gap.
Yeah.
We talk about the difference between declarative knowledge, that's knowing what something is, which language models are fantastic at, and then there's procedural knowledge.
The step-by-step.
The step-by-step. The explicit sequential actions you need to take to get something done in a very specific environment.
So it's one thing for an agent to know what data analysis is in a textbook sense. It's a completely different thing for it to know that at our company, data analysis means you first pull data from this PostgreSQL database.
Using this specific API key.
Right. Then you run it through our proprietary Python script that has to clean it according to, GDPR rules. And then the final output has to be in this very specific Tableau workbook template.
That is the perfect example. It's those user-specific contextual details that a general model could never, ever guess. It's the 5 steps, the 3 forms, the 2 weird legacy tools your company still uses. And that context has to be loaded on demand in a very organized way. That's what the folder gives you.
And the fact that this is an open, standardized format that just creates this incredible leverage, the documentation calls it an aha moment because it benefits 3 different groups all at once. Let's start with the people actually building these things, the skill authors.
Right. So for a skill author, and that could be a developer, a data scientist, a legal expert, the big win is reusability, massive reusability. Before a standard like this, you might build this brilliant tool for, say, parsing some weird old invoice format.
Yeah.
But then you'd have to basically rewrite it or repackage it for every single different AI agent your company decides to try out.
You get this vendor lock-in, but through custom integrations, it's a nightmare.
It's a nightmare. But if you build it to the Agent Skills Open Standard, You build it once, you create that PDF processing skill with its scripts, its instructions, and because it's a standard, it's like a universal plugin. It dramatically lowers the pain of switching platforms.
So your work has a much longer shelf life.
A much longer shelf life and a much wider impact. It totally changes the economics of building these tools. You're not just coding for one platform anymore. You're creating a skill for the entire standard, for the ecosystem.
Okay, so that's the author. What about the second group, the agent products themselves, the platforms?
For them, this is a huge strategic win. By just supporting the format, their agent product instantly gets these out-of-the-box expansion capabilities. They don't have to go and build 10,000 little specialized functions themselves. They just have to build the mechanism to read and use the standard.
It's kind of like the difference between building an old-school operating system where every single app is baked in versus building an iPhone that just supports the App Store.
That's the perfect analogy.
Yeah.
By supporting the standard, they make their product instantly more valuable because now users can just drop in skills that their own teams built, or skills from a third party, or even open source ones. It accelerates the whole ecosystem.
Right. And that brings us to the third pillar, which to me seems like the most transformative for big companies, capturing the organizational knowledge itself.
This is the real sea change.
Yes.
This is moving from like passive documentation that sits in a dusty binder somewhere to active executable knowledge.
Right.
Agent skills give you a formal, consistent way to capture that squishy, proprietary knowledge, the stuff that's usually stuck in emails or just in one expert's head. And you package it up. It goes portable, it's version controlled. You're turning your internal processes into reusable, auditable, and automatable workflows.
I see that immediately. It's no longer a PDF of a standard operating procedure that the agent has to try and read and interpret and maybe get wrong.
Exactly.
It's a digital executable folder that the agent can just run. That guarantees consistency.
Consistency and auditability. Because it's all codified, you can track the execution. And when we look at the specific capabilities this unlocks, it's more than just definitions.
Yeah, the docs mention domain expertise first, which we've been hitting on. The key examples they use are things like company-specific legal review processes or unique data analysis pipelines. These are not simple tasks.
No, these are things you normally need a senior person for. But beyond just capturing existing expertise, skills can also enable brand new capabilities. We think of these models as only being able to do what they were trained on, but skills let you bolt on totally new functions.
How so?
Well, the docs mention things like creating presentations. That's a complex multi-step task. It involves using tools, applying templates, pulling data. Or another one was building MCP servers, which is, some kind of complex infrastructure task that would absolutely require command line scripts.
Things that demand a very specific sequence of steps, a specific set of tools, the very definition of procedural knowledge.
Exactly. And once you package that knowledge, you get repeatable workflows. This is huge for enterprises. Think about a complex monthly report like a quarterly business review.
Oh, the QBR. The bane of so many people's existence.
Exactly. It's this multi-step, error-prone human process. If you turn that into a skill, it becomes consistent. It's reliable.
And that's where the real return on investment comes from. The agent follows the exact same process, uses the exact same scripts and templates every single time. For anything touching finance or compliance, that consistency is it's non-negotiable.
You can't have variation there. And finally, tying it all back to the open standard, the last big capability is interoperability. The whole format is designed so that the skill you write today can be used on different agent platforms tomorrow.
So your knowledge becomes a portable asset.
A portable asset. If you switch vendors in 5 years, you don't lose all that codified procedural knowledge you spent years building. You just take your skill folders with you. It strategically decouples your knowledge from the execution platform.
Okay, so we've established the why. Now we have to get into the nuts and bolts, the how. If I'm going to build one of these, I need the blueprint. What are the absolute unbreakable rules of the skill structure?
Right, because if you get the format wrong, that whole efficiency mechanism we're going to talk about, progressive disclosure, it breaks completely.
So system reliability starts with the file structure.
It absolutely does, and it starts simple. A skill is defined by a directory, a folder. And inside that folder, you must have, at a bare minimum, one file, SKILL.md.
Skill, all caps, .md.
Correct. And here's the first key constraint that trips people up. The name of that parent folder must match the skills name field, which is defined inside that file.
Okay, so the folder itself is part of the contract. If I'm making a skill called invoice extractor, the folder has to be named invoice extractor, and inside is invoice extractor skill.md.
You've got it. And that skill.md file is the brain. Its format is simple, but like I said, very strict. It must start with YAML front matter.
The machine-readable part.
The machine-readable metadata, exactly. And that's immediately followed by standard markdown content, which is the human-readable part.
All right, let's break down that front matter. This is the little index card the agent reads first.
Yeah.
What are the absolute must-have required fields?
There are two. The first is the name field. This is the short identifier for the skill, and it is by far the most constrained field.
Why so rigid?
Because the agent's internal systems use it for everything. Referencing, parsing, file system navigation. The spec says it can be a maximum of 64 characters, and it can only, and I mean only, contain lowercase letters, numbers, and hyphens.
No spaces, no underscores, no uppercase?
Nothing. It's all about ensuring compatibility across different operating systems, Windows, Linux, you name it, and guaranteeing that the identifier is clean for automated parsers. If you allow weird characters, you get into all sorts of trouble with escaping and path issues.
So it's a robustness feature that looks like a restriction.
It is. And there are even rules for the hyphens. The name can't start or end with a hyphen, and you can't have two hyphens in a row like my skill.
Okay, so PDF processing v2 is good.
Perfect. But PDF processing v2 with a capital P is bad. And PDF processor is bad because it starts with a hyphen. It's that specific.
Okay, that's the name. What's the second required field?
The description. And this one is more flexible, thankfully. You get between 1 and 124 characters. But what it has to convey is critical.
What's that?
It has to do two jobs. First, it has to clearly describe what the skill does. Second, and this is the really important part for the AI, it has to describe when to use it. It needs keywords to help the agent match a user's request to that specific skill.
Ah, so it's the trigger. The agent is constantly looking at the user's prompt and comparing it against this library of descriptions. If your description is bad, your skill never gets picked.
It'll just sit on the shelf.
Yeah.
The documentation gives a great example of this. A bad description is just helps with PDFs. Totally useless. The agent has no idea if it's the right tool. A good description is something like, extracts text and tables from PDF files, fills structured PDF forms, and merges documents. Use this skill when the user mentions forms, document extraction, merging, or manipulating PDFs.
See, that gives the AI actual actionable intelligence. It minimizes the chance the AI just guesses wrong.
Right, it's prompt engineering for your tool library.
Okay, so name and description are required. Now for the optional fields. Let's start with license.
The license field is pretty straightforward, but crucial for any kind of corporate or open source environment. You can specify a common license name, like MIT, or you can reference a file inside the skill folder, like licensee.txt. It's for compliance and IP tracking.
Makes sense. Next up is compatibility. This sounds important.
It is. I like to think of it as the skill's pre-flight checklist. It's a text field, up to 500 characters, where the author declares everything the skill needs to run properly.
So if my skill has a Python script that needs a special command line tool, this is where I say that.
Exactly. You could write something like, compatibility requires Git, Docker, JQ, and access to the internet.
And what does the agent do with that?
It checks its own environment. If it reads that and knows it doesn't have Docker installed, it won't even try to run the skill. It'll just report back to the user that the requirements aren't met. It prevents so many frustrating silent failures.
That's smart. Okay, then there's metadata.
Metadata is basically a free-for-all. It's just a place for arbitrary key-value pairs that your organization might want for tracking. You could put in the author.legalteam, or a version, 2.1.3. It's just a structured space for your own custom info.
And what about this experimental one, allowed tools?
Ah, yeah. That one points to the future of security. It's a space-separated list of tools the skill is pre-approved to use, like bash, git, or read. It's a whitelist.
I see. So it's about locking down the execution environment. You're telling the agent, this skill is allowed to use git, but nothing else from the bash shell.
Precisely. It's a very granular security control that we'll probably see become more common.
Okay, that's the front matter. Now, the main event, the body of the skill.md file, the markdown section with the instructions.
Right. And remember, this part is only loaded after the agent decides to activate the skill. And while it's just standard markdown, the documentation really pushes some best practices.
Like what?
They strongly recommend you structure it with clear step-by-step instructions. You should include examples of what the input and output should look like so the agent can check its own work. And you should document common edge cases to help it avoid simple mistakes.
And this brings us back to the efficiency point. The whole body gets loaded into context, so you have to be concise. You can't write a novel in here.
You absolutely cannot. The hard recommendation from the spec is to keep the SKILL.md body under 500 lines, or roughly 5,000 tokens. If your instructions are longer than that, you need to break them up and move the extra detail into the optional directories.
Which is a perfect segue. Let's talk about the rest of the toolkit, these optional subfolders that really give the skill its power. There are three main ones.
The first, and maybe the most powerful, is the scripts directory. This is where you put your executable code. The Python scripts, the bash scripts. This is where the heavy lifting happens.
And the docs must have some rules about these scripts.
Oh yeah. They have to be either totally self-contained or all of their dependencies must be declared up in that compatibility field we talked about.
And what about the code itself? It needs to be robust, I assume.
It has to be. You need clear error messages. If the script fails, the AI needs to be able to read that error and understand what went wrong, not just get a cryptic crash log. It needs to handle edge cases gracefully.
Makes sense. The second folder is references. This is for extra documentation, right? Why not just put it all in the main file?
Because of that progressive disclosure model, these reference files are loaded strictly on demand as needed.
Okay, give me an example.
So your main skill.md instructions might say, Step 3, validate the customer ID format. To do this, consult references customer-ed schema.md to confirm the required regex pattern.
Ah, so the agent only reads that schema file at the exact moment it needs to do the validation. It's not sitting in the context the whole time.
Exactly. It keeps the context window clean and focused. You don't read the entire encyclopedia just to look up one word.
Very efficient. And the last folder is assets. What goes in there?
Assets is for any static resources the skill needs. This is often things like templates, a Word document template, a configuration file template. It could also be data files like a CSV lookup table, or even images like a diagram that the instructions refer to.
So when you put it all together, the skill is this complete self-contained little ecosystem. You have the YAML front matter for the machine identity, the markdown body for the human readable instructions, and then the scripts, references, and assets as the actual toolkit.
That's it. And that rigid, clear structure is what enables the whole system to be so efficient.
Which brings us to the core technical mechanism, efficiency. We've said it a few times, but let's really dedicate some time to this. If I'm an agent and I have access to, say, 500 different skills in my organization, loading all of them into my context window for every single user request would be
impossible.
Yeah.
It would be insanely slow and prohibitively expensive. It would completely defeat the purpose of using an AI.
Right. So the whole system is built on this architectural pattern to avoid that. You called it progressive disclosure.
That's the one. It's a three-step process designed to manage the cost of context by only loading tokens when they are absolutely 100% necessary.
Okay, walk us through the 3 steps. Step 1 is the initial low-cost handshake.
That's the discovery and metadata load. When the agent system starts up, it scans all the directories where skills are stored. But, and this is the key, it only loads the name in the description from the YAML front matter of each skill.
And the documentation puts a number on this. It says this initial load is typically only about 50 to 100 tokens per skill.
Just think about how efficient that is. If you have 1,000 skills, you're only loading maybe 100,000 tokens of metadata to know the entirety of what you're capable of doing. If you tried to load the full 5,000 token instruction set for each, you'd be at 5 million tokens before the user even typed a word.
It's like you're just loading the table of contents for the entire library, not reading every single book.
A perfect analogy. It's just enough for the model to know if a skill might be relevant.
So the user says, I need to compile this quarter's financial data. And the agent zips through those 100 token descriptions, finds one called QBR reporting, and says, aha, this looks like a match, which brings it to step 2.
Step 2, activation and instructions load. Only after the agent makes that match does it then go and load the full body content of the skill.md file into its working context.
And this is where it consumes that larger chunk of tokens, the 500 lines or 5,000 tokens. Now it has the detailed playbook. It knows the sequence of operations, the tools it needs, everything.
Exactly. And that leads to the final, most granular step. Step 3 is execution and resource load. This is where the deepest files, the Python code and scripts, the detailed docs and references, the templates and assets are loaded. And they are loaded only as needed, during the execution of the task.
So the agent doesn't even read the Python script until the instructions say, okay, now it's time to run scripts clean data.py.
Correct. It only reads the file right before it executes it. That whole process, that just-in-time loading, is the engine that makes the whole thing scalable and cost-effective.
It's all about keeping that active context window as small and as relevant as possible at all times.
That's the name of the game.
So this leads to the two main ways an agent can actually integrate with this format. The docs call them file system-based agents and tool-based agents. What's the fundamental difference?
The difference is really about the agent's operating environment. A file system-based agent is one that lives inside a normal computer environment like a Bash or Unix shell. The documentation calls this the most capable option.
Why is it more capable?
Because it can interact with the skill folder directly, using native operating system commands. It can literally navigate the directories, read the files, execute the scripts itself.
So to activate a skill, it might issue a command like cat path to me is SKILL.md.
Precisely. It treats the skill like any other set of files on the computer. It's very direct, very powerful.
Okay, so what's the alternative? The tool-based agents.
These agents operate in a more abstract world. Think of a proprietary cloud environment or a SaaS product where the agent doesn't have a raw shell to play in.
It can't just cat a file.
Exactly. So for these agents, the developer has to create specific tools or API functions that act as a bridge. The agent still gets the skill's metadata and instructions, but when it needs to run a script, it doesn't execute it directly. Instead, it calls a predefined function, like run skill script, QBR reporting, cleandata.py.
That sounds like more work to set up and maybe a little less flexible. Why would you choose that path?
One word: security. It's all about control. With a tool-based agent, you have a much tighter security perimeter. In a big cloud environment, you probably don't want your AI model having direct, unfettered shell access to your infrastructure.
No, definitely not.
The tool-based approach forces every single interaction, every file read, every script execution to go through an audited, permissioned API layer that you control.
Yeah.
So you trade some raw capability for a massive gain in security and control.
That makes a lot of sense. So regardless of the path, the agent first needs to know what skills exist. You said it injects the metadata into the system prompt. How is that structured?
Yeah, the spec gives a recommended format, which is an XML structure that works really well with models like Claude. It's the standardized way to present that index card of skills to the agent.
So what does that XML look like?
You have a main available skills tag that wraps everything. Then for each skill, there's a skill block. And inside that block, you have the two things we've been talking about: a name tag and a description tag.
And there's a third one, isn't there? The location.
Right. The location tag holds the absolute file path to the skill.md file. And this is where the two agent types diverge. For a file system-based agent, that path is essential. It needs it to go and cat the file.
But for a tool-based agent...
If for a tool-based agent, you can often leave it out. The agent calls the tool by the skill's name, not its file path, so the location on disk is irrelevant to the model itself.
So that initial prompt injection is just the name, the description, and maybe a path. That's it. It just confirms that whole architecture. It's so lean.
It's incredibly lean. It's a masterclass in efficient prompt engineering, really.
Okay, so we've built this amazing picture of these capable agents that can run custom code from a scripts folder. And this, of course, brings us to the elephant in the room: security. This sounds inherently risky.
It is. Hugely risky. You're moving from just reading text to executing code on what could be very sensitive systems. If you don't nail the security, the whole concept is a non-starter in any serious enterprise.
So what does the specification say about this? How do you manage that risk?
The documentation is very clear that security is not an optional extra. It's a core design requirement. It lays out 4 key security pillars that any system supporting agent skills must implement.
Let's go through them. What's the first and most important layer of defense?
Sandboxing. This is absolutely non-negotiable. Any script from a skill must be run in a completely isolated environment. A container, a VM, some kind of constrained service.
The goal being to prevent a malicious script from breaking out and, reading files it shouldn't or damaging the host system.
Exactly. The sandbox has to strictly limit what the script can do, what files it can see, what network connections it can make, how much CPU it can use. If a skill is for processing invoices, it should only be able to access the invoice directory and maybe one specific API endpoint and absolutely nothing else.
That sounds incredibly complex to set up correctly.
It is a major engineering challenge, but a failure here is a catastrophic failure for the whole system.
Okay, so sandboxing is pillar 1. What's next?
Allow listing. This is about managing trust. Instead of a run anything model, You shift to a run only what has been explicitly approved model.
So every single skill has to go through some kind of internal review process before an agent is even allowed to use its scripts.
That's the idea. Your security or compliance team vets the skill, maybe even cryptographically signs it, and adds it to an approved list. This dramatically reduces the risk of someone loading a malicious skill they found on the internet.
So it adds organizational friction, but for a very good reason.
A very good reason. And you can get even more granular. You can allow us specific tools within a skill, which ties back to that experimental allowed tools field. You might say, this skill can use Git, but it can't use curl.
I see. Okay, Pillar 3 introduces a human into the loop. Confirmation.
Yes, this means that for any action the agent wants to take that is deemed high risk or irreversible, it has to stop and ask the user for permission.
So if a skill script is about to delete a database or transfer money,
The agent has to pause and say, I am about to execute a script that will permanently delete the customer database. Are you sure you want to proceed? And it waits for a yes from the human.
that seems like a critical safeguard. It protects against not just malicious skills, but also the AI just misunderstanding the user's intent.
It's the final firewall. It keeps the human in control of the most consequential actions.
Okay, and the final pillar is logging.
Logging is all about auditability and accountability. The system must keep a detailed record of everything. Which skills were activated, which scripts were run, what resources were accessed, what the outcomes were.
So if something does go wrong, you have a complete forensic trail to figure out how and why.
Precisely. For any company in a regulated industry, finance, healthcare, this kind of auditable log isn't just a good idea, it's a legal requirement.
So you need all four: sandboxing, allow listing, confirmation, and logging. Without them, this is just too dangerous for a real business environment.
100%. They form the complete security perimeter.
Okay, let's pivot from security to best practices for the people actually writing these skills. We've talked about the strict file structure, but what makes a skill effective and efficient?
The number one rule, and we've said it before, is conciseness. You have to treat that token limit like it's sacred. Keep your metadata down to that 5100 token range. Be ruthless in editing the SKILL.md body to stay under 500 lines.
It forces the author to really think about what information is essential for the activation step versus what can be offloaded to a reference file.
Which leads right into the next best practice: proper file referencing. The spec is adamant that when you reference a script or a document, you must use relative paths from the skill's root directory.
So you'd write scripts cleanup.py, not home user skills, my skill scripts cleanup.py.
Exactly. Why do you think that is?
Portability.
Portability. With relative paths, you can move that entire skill folder anywhere on the system, and it will still work perfectly. Absolute paths would break immediately. The docs also warn against creating these deep, nested chains of references. Keep it simple.
Yeah, you don't want the agent having to load 10 different files just to figure out one step. It would kill performance.
It would be a nightmare. And the final best practice is really about leaning into the format's self-documenting nature.
Meaning the structure itself should make it easy to understand.
Yes. The clear separation of the machine-readable YAML and the human-readable Markdown means that anyone, a new team member, an auditor, can open that skill.md file and immediately grasp what the skill does, what it needs, and how it works. It makes the skills easy to manage, easy to audit, and easy to improve over time.
It turns a process into a living, transparent digital asset.
That's the goal.
This has been an incredibly deep look at this blueprint. It's clear that the Agent Skills Open Standard is so much more than a file format. It's really an architectural solution to a huge scaling problem in AI. Let's try and summarize the key takeaways for everyone listening.
I'd say the first one is that agent skills standardize expertise. They use this simple but strict folder structure, centered on that skill.md file, with its YAML front matter for the machine and markdown body for the human.
Second, the biggest technical challenge, the expensive limited context window, is solved by that clever progressive disclosure mechanism. It's all about efficiency. Load the tiny bit of metadata first, then the instructions, and only then the deep resources, as needed.
Right. And third, the format is flexible enough to support both those powerful, direct file system-based agents and the more secure, abstracted tool-based agents.
Yeah.
And because it involves running code, those security measures we talked about, sandboxing, logging, they aren't optional. They're table stakes.
And for you, the learner, the reason this matters is that this standard is defining how your organization's most valuable IP, its unique processes, will be captured and automated. This is the mechanism that turns those messy internal workflows into clean, portable digital assets.
Which brings us to a final provocative thought to leave you with. If your organization's core knowledge, the very thing that gives you a competitive edge, is now packaged up into these standardized, version-controlled, portable files, what does that do to the idea of intellectual property? When the secret sauce for a high-value task is no longer locked away in someone's head or a dense manual, but is now a file that can be run by any compatible AI, how does that change the game? What becomes the new source of competitive advantage when the recipes themselves become standardized and portable?
The value shifts from the knowledge to the operationalization of it. A lot to think about there. Thank you for joining us for the deep dive. We look forward to seeing what specialized skills you all build and deploy.
Until next time.